I just can't get enough. I just can't get enough of binary and subnetting. This is, I think, my third video on this. But I want to run another exercise, and I want to expound on it a little bit. Are these on the same subnet? So there's /13s, which mean the mask is a contiguous string of ones starting over here, extending to the 13th bit. So we know that we got 8 bits in this first octet. We got 8 bits in every octet. What am I talking about? We got 8 bits in every octet, and the mask extends past the 13th bit. So since that is the octet in question, that second octet, first, second, third, fourth, the second octet, blow it up, draw your scale, 1, 2, 4, 8, 16, 32, 32, 64, and 128. Is 100 greater than or equal to 128? The answer is no, it's not. Put a 0. Is 100 greater than or equal to 64? The answer is yes, it is greater than. So you put a 1 there. Write your 100 over here. Then since the answer is yes, bring the 64 over, subtract it, you get 36. Is 36 greater than or equal to 32? The answer is yes. Put a 1, bring the 32 over here, subtract, you have 4. Is 4 greater than or equal to 16? No. Is it greater than or equal to 8? No. Is it greater than or equal to 4? Yes. Bring that 4 over here, subtract, you have 0. You're done. Everything else is zeros. Okay? So that's the first one. Let's do the second one. Repeat. Is 101 greater than or equal to 128? No. Put a 0. Is 101 greater than or equal to 64? Yes. Put a 1. Start by putting your 101 here. Bring that 64 over. Subtract. It's 37. Is 37 greater than or equal to 32? The answer is yes. Put a 1. Bring the 32 over. Subtract. You got 5. Is 5 greater than or equal to 16? No. Is it greater than or equal to 8? No. Is it greater than or equal to 4? Yes. Bring the 4 over. Subtract. You have 1. 1 greater than or equal to 2? No. Is it greater than or equal to 1? Yes. Bring the 1 over. Subtract. You have 0. You're done. So the mask is 13. I blew this octet up. So that means this dot and this dot literally is right here and right here. So this is bit 8. You have 8 bits here. So this is the bit 8 boundary. Bit 9, bit 10, bit 11, bit 12, bit 13. This is where the mask is. And so what do we know about a net mask? A net mask says everything to the left is network bits, everything to the right is host. If you're trying to find out if these two IP addresses are on the same network, all you have to find out is, do these network bits match? If the answer is yes, and you can stare and compare, and you can see that they're both on the same subnet. So the answer is yes, they're on the same subnet. Now, next question. What subnet is that? What is the network ID? Well, you know the definition, or you should know the definition of a network ID is that all the host bits are set to 0. So, if these are all host bits going this way, and you start by flipping that back to 0, and then we just know that all these are 0 going that way, because look, this is the second octet. You got the third octet and the fourth octet out here, but they're all zeros all the way across. Okay, so that means you add up all the ones in this portion. The placeholder values, you add them up. So you add up 64 plus 32, that's 96. And that's converting it back to decimal. Write that up here. 99.96.0.0/13 is the network ID. I'll pause the video for a moment and I'll repeat that. To find out what the top end of a subnet is, that's the broadcast. you set all of your host bits to 1. So we know this is the /13 divider. Let's just start by flipping this to 1. Then we know all other host bits this way are set to 1, which means the third and fourth octet, when we convert all those ones back to decimal, you're going to have, if you didn't know that, when you set all of the binary places to 1 in an octet, it equals 255. So when you set all those to 1, you have 255. Now the question becomes, what is this second octet? So it's always kind of tricky to think about it in your head, but it's true. You have to, even though your mask divider is on the 13th bit, you have to consider the whole 8-bit string when converting it back to decimal. Okay, so we know this is 96. 96 plus 7, 4 plus 2 plus 1, right? 96 plus 4 plus 2 plus 1 is 10, 11, 12, 13. 3 carry the 1, 103. 103, 99. So look at that. These two IPs are on the same subnet. This is the top of the subnet. Excuse me, that's the bottom of the subnet, which equals the net ID with a lot of IP addresses in here to include the two that were part of our problem. And then this is the bcast, the broadcast for that subnet. All right, it's a sloppy 9, sorry about that. So, hope that was helpful. One more subnet exercise in the books.